Hello, and welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem number 8, string to integer. Let's read the question prompt. Implement the myAtoi function, which converts a string to a 32-bit signed integer. What we want to do is read in and ignore any leading white space. Then we want to check the next character, if not already at the end of the string, is a minus or a plus. We can read this character in if it is either. This determines the final result being positive or negative. Assume the result is positive if neither is present. Then read in the next characters until the next non-digit character or the end of the input is reached. The rest of the string is ignored. Convert these digits into an integer, i.e. the string 123 should become 123. If no digits were read, then the integer is 0. Change the sign as necessary from step 2 where we parsed whether it was positive or negative. If the integer is out of the 32-bit signed integer range, then clamp the integer such that it remains in the range. Specifically, integers less than minus 2 to the 31 should be clamped to minus 2 to the 31, and integers greater than 2 to the 31 minus 1 should be clamped to 2 to the 31 minus 1. Return the integer as a final result. Note, only the space character is considered a white space character. Do not ignore any characters other than the leading white space or the rest of the string after the digits. Okay, so we read the really long question prompt. Let's look at an example now. Okay, we read the question prompt. Now it's time to look at an example. Let's look at this input, s equals 4139 with words. So we should parse 4139. Why is that? Remember, the first thing that we do is handle any leading white space, which we don't have here. Then what we want to do is we want to check for any positive or negative signs in our string. We don't have that here, so we don't have to worry about it. Then we start parsing. So first we're going to parse our 4, then we're going to parse the 1, then we parse the 9, then we parse the 3, and then we get to a white space, which it tells us, okay, the second we see a, non-digit character here, then we just stop. So our iteration stops here, and we simply return this as an integer. And since, we convert it and we check, okay, well, this is still within our signed integer range, so we don't have to do any sort of clamping, so we're good. So we can simply just return 4193. What about this string? S equals, some space here, minus 42. Well, remember that the first thing that we do is get rid of any leading white space. So we can think of this string as actually just being negative 42 after we strip out any leading white space. Now what we want to do is check for any positive or negative signs. This problem does have a negative here. So we'll have to return our results, whatever we parse from the numbers, as a negative. So then we start parsing. So first we parse the 4, then we parse the 2, and then we actually reach the end of the string. So it's time to return our result. Now we parsed 42, but remember we had the negative sign, so we need to say negative 42. And we also need to check whether or not, negative 42 is between the, signed integer range. So is it in this range? Yes, it is. So that means that we can simply return, oops, there's negative 42. So we can simply return 42 here. So that's the approach we want to take for this problem. Let's go over kind of the algorithm. The first thing is going to be, strip white space, right? Strip leading spaces. And this is really painful to write out. And then the second thing we want to do is check for positive or negative, right? Positive or negative sign in the beginning. And then we want to parse digits. And then after we parse our digits, we want to check the, integer range, right? Check num, between, what is it going to be? Negative 2 to the 31 and, 2 to the 31 minus 1. So that's what we want to do, right? We want to make sure that it's in that range. And if it's not, then we need to clamp it down. So, well, I guess, yeah. So that's the algorithm that we want to use here. It's relatively simple. This problem is annoying because there's a few edge cases, but once we go into the editor, we'll handle all of those one by one, and you'll see that this problem is actually really easy to solve. So let's go to the code editor and we'll write it out. Okay. We're now in the code editor and it's time to write the code. Remember that the first thing that we want to do here is to strip out any leading white space in our string. So let's do that now. So we're going to say string is going to be equal to string.lstrip. So lstrip will get rid of any of that leading white space. Now what we need to do is we need to check another edge case. This problem is more of a question around edge cases than it is the actual parsing of numbers. So I can see why interviewers like to ask this one. Now what we need to do is after we've stripped out the white space, we need to check whether or not we actually have a string here. It could be the case that the string was entirely white space, we got rid of it, and now our string is empty. So there's nothing to parse. So at this point, we simply want to return 0 if the string is empty. So we're going to say if not s, we're going to say return 0. Now what we want to do is we want to start processing our string. And we're going to do this with a while loop and then parsing it index by index and accumulating while we still have valid things to accumulate. So we're going to say I equals 0. And remember that what we need to do is check whether or not we have a positive or a negative sign at the beginning. This is the only time that we're allowed to have one of those, is at the beginning of the string. So we're going to use sign equals 1 to signify that we have a positive number, and it'll be -1 if the sign is negative, right? Because then at the end, we can take whatever number we parsed and simply multiply it by the sign. If it's positive, no problem, it'll stay the same. If it's negative, obviously multiplying by -1 will turn any positive number negative and return the same number. So that's why sign is going to be 1. Now we need to check for that character. So we're going to say if s of I equals to a positive, then we're simply just going to increment the I index by 1. We already have the fact that sign is 1, so we don't need to reset it. Otherwise, we're going to say if s of I, so basically if the first index is a minus sign, then we need to still move I up, and now we need to say that sign is going to equal to -1. Cool. Now we can start parsing our value. So we're going to say parsed is going to be 0. And we're going to say while I less than len s. So we're going to parse, from left to right. And we're going to say that the current number is going to be s of I. And we're only allowed to parse digits at this point. If we see anything other than a digit, then, we know that we have to get rid of it. We can stop our iteration here. We know that we can't go any further because something's wrong with our input. We can only parse digits. We're going to say if not cur.isDigit. So basically we're just checking whether the current number is a digit. Then what we want to do is we would just want to break out of this loop. We don't want to do anything here. We just want to break out, because that means that we've seen some sort of invalid input. So we should just return whatever we were able to parse and ignore the rest. So otherwise, if we have a valid digit, then what we want to do is we want to say parsed is going to equal to parsed times 10 plus integer value of whatever cur is. So this is how you parse numbers when it's going serially through a string. So if you've never seen this before, I'll just do a quick introduction to why this works. Whoops. So say we have the string 1, 2, 3, and we're parsing from the left. So, the first thing that we're going to parse is this 1. So, our parsed, initially starts at 0. And now parsed is going to be assigned to whatever parsed times 10 is. So obviously 0 times 10 is 0, plus the integer 1, right? So that means that parsed now equals 1. Then we get to this 2. So, parsed times 10 will now give us 10 plus, the integer, whatever cur is. So it's 2. So this means that parsed is now 12, right? Cool. Then we get to the 3. So we multiply this again by 10. So we have 12 times 10 plus the integer of whatever cur is, so 3. And we get 1, 2, 3. So you can see how it works to basically, handle the fact that we parse the 1 first, except for this is like, the largest. So this is the 100ths value, but we parse it first. So that's why we multiply by 10 each time to account for the fact that we're parsing from left to right, except for that, it needs to be multiplied by 100 actually. So that's how we handle it. So if you've never seen this before, this is usually the pattern for parsing out an integer from a string when going left to right. So getting back on track, that's how we handle parsed here. And at the end, what we want to do is we just want to increment our I to continue parsing through our string. So at this point, either our while loop will end because we reached the end of the string and we were able to parse everything that we needed, or we hit something that wasn't a digit and we just need to return whatever we were able to parse. Remember that we can't just return parsed times the sign. We actually need to check whether parsed is within the valid, where does it say? If it's in the 32-bit signed integer range. So right, negative 2 to the 31 to 2 to the 31 minus 1. So we have to make sure we're within that range. And if we're not, then we have to clamp it down to fit inside that range. So now we need to apply our signed. So we're going to multiply parsed by whatever sign was. So it's either going to be positive or negative. And now we can do the clamping. So we're going to say if parsed is greater than 2 to the 31 minus 1, then we need to clamp it down to 2 to the 31 minus 1. So we're simply going to return 2 to the 31 minus 1 in the case that it's too big on the positive side. And then we're going to check if it's too small. We're going to say else if parsed is actually less than or equal to minus 2 to the 31. Minus 2 to the 31. Oops. 2 to the 31. Then we want to return 2 to the 31. Oh, minus 2 to the 31. Sorry about that. And I keep double here. Otherwise, what we need to do is simply just return parsed because it's within the range. So we're all right there. So what we're going to do is submit this, make sure that it works. And for some reason, I seem to have made a bug. What did I do here? Oh, I didn't even return parsed. Whoops. Okay, that's okay. That's embarrassing. Or anyway, okay. So once we fix that bug, we can see that we fixed the code here. So what is the runtime complexity of our algorithm? Well, this else strip is going to take big O of n time. In the case that our entire string is actually white space, it's going to take big O of n time to do that. So this else strip is going to cost us, big O of n. And what we need to do is we need to parse the entire string. So even in the case where we don't have anything to strip, we still have to go through the entire string. So we're still bounded by big O of n in the time complexity because we'd have to parse out the entire string s from left to right. So time complexity wise is going to be, big O of n. Space complexity wise, we're not actually defining any extra space here. All we're doing is creating a pointer I, and I guess a sign to and parsed, which is going to hold our, data here. But these are all just constant space allocations, right? They're just integer values. So we can consider this as big O of 1 space. So that's going to be how you solve this problem. It's not too complicated. I think it's relatively simple. You're just going from left to right, parsing values. I think the complexity of this problem really comes from the edge cases, right? You first need to make sure that you stripped all the white space. Then you need to make sure that you actually have a string to parse. Then you need to handle the signs. Then you need to do the parsing, make sure that you break when it's not a digit, then handle the fact that you need to clamp things down. There's just a lot of things floating around and it's easy to miss one of these. So make sure you kind of study this problem, understand what it's looking for. This is definitely one where you want to work with your interviewer to like really establish all the edge cases and understand what you're really trying to solve. Because if you just try to jump into this and you miss something, it's going to be a really bad coding signal for you. The interviewer is going to be like, okay, this guy just doesn't ask enough questions. He jumps into the problem without knowing what he's doing. Then he has to go back, right? It just doesn't look too good on you as a candidate if you're doing that. So you want to establish all the things that you're looking for, identify those edge cases before you start writing the code. Because if you don't, then it's going to look bad on you as a candidate. And if you make mistakes, it's going to weigh, twice as heavy because the interviewer is like, well, you didn't even ask these questions. You jumped right in, sucks to be you. So that being said, be careful with the edge cases, ask your interviewer, any clarifying things that you need to, and then start writing the code once you have identified, your plan of action. So that's going to be this problem. I hope you enjoyed this video. If you did, please leave a like, comment, subscribe. If there's any other videos or topics you'd like me to make videos on, please comment in the comment section below, and I'll be happy to get back to you with those videos. And otherwise, happy coding. Bye.